to do a whole bunch of word problems in this lesson, and we're going to be using our calculator. So get your calculator out and ready. And if at any time I'm going a little faster than you are, just pause the video, get some of your work done, and then come back and check how you're doing. All word problems today. Okay, let me close this. And here we go. Number 20 from your book, actually. Number 20 says the length of a rectangle is 2 feet more than the width. I'm going to let x equal the width, which means the length has what expression? X plus 2. So we've got our width, we can label it x, and our length, x plus 2. It says the area of the rectangle is 2 square feet. So we know our area formula for a rectangle is length times width, and it's telling us that the area is 2. We know that our length is x plus 2, and our width is x. So we're going to set up a real simple quadratic. You want to get it set equal to 0, so bring this 2 over, and we have x squared plus 2x minus 2 equals 0. So of course, we just learned the quadratic formula and completing the square. This quadratic will not factor, so we need to choose one of those methods to solve for x. So I chose the quadratic formula. You should have this memorized by now. A value is 1, B value is 2, C value is negative 2. And let's go ahead and sub those in. X equals negative B. Plus and minus square root, b squared is 4, minus 4 times 1 times negative 2, all over 2 times a. So negative 2 plus and minus square root of 4 plus 8, double negative, all over 2. Square root of 12 can be simplified. And because 2 goes into both of these, I can reduce. And we have some possible solutions. So remember, x is the length and the width, or related to the width, and x plus 2 is the length. And so in looking at these two roots, negative 1 minus the square root of 3 and negative 1 plus the square root of 3, I'm going to reject this top one because a negative minus something is very negative and it cannot represent a length. So here we have x equals negative 1 plus the square root of 3, which is our width, and our length. Therefore, if I added 2 to that, add 2 to negative 1 plus the square root of 3, and you get 1 plus the square root of 3. So let me change this up a little bit and write width and length. Second example. Says the length of the base of a triangle is 6 feet more than the length of the altitude to the base. So we're going to let x equal the altitude, and therefore the base is 6 feet more than the altitude. You can draw these in, and the base is down here. Okay. The area of the triangle is 18 square feet. We know that the area formula is 1/2 base times height for a triangle. So we have 18 is 1/2 the base times the height. And here we go. To simplify a half on this side, I'm going to multiply both sides by 2. And distribute my x. My fraction is now gone. Let's bring that 36 over. By subtraction. And again, we have a quadratic that we need to solve that does not factor. Let's use completing the square this time. So my quadratic is x squared plus 6x minus 36 equals 0. I'm going to bring the 36 over. X squared plus 6x leaves some room, equals 36, leaves some room. Adding on the left, adding on the right to keep it balanced. With completing the square, remember we take half of 6, which is 3, and square it. So we add 9, add 9. On the left, we have x plus 3 times x plus 3, also known as x plus 3 all squared. On the right, we have 45. To get x alone now, we square root both sides, square root 45 plus and minus. So x plus 3 is equal to the positive and negative square root of 45. I'm thinking right now I want to simplify that. Since it's square root of 9, square root of 5, it's 3 square root of 5. Subtract 3 over, and we have our solutions, possible solutions for x. Negative 3 minus 3 radical 5, and negative 3 plus 3 radical 5. Again, since it's a word problem and x is actually a length of something, this negative minus something is rejected. So our solution, negative 3 plus 3 square root of 5, would be the length of the base, or sorry, length of the altitude. And the base is 6 more than that. So negative 3 plus 3 radical 5 plus 6 gives me 3 plus 3 radical 5. There's my altitude, there's my base. Next question. The next question has to do with a theorem that you learned in geometry. The altitude CD to the hypotenuse AB of a right triangle separates the hypotenuse into 2 segments. So we need to go from C and draw an altitude to the hypotenuse. Altitudes are perpendicular, and we're labeling that CD, altitude CD. So it's showing you that it cuts it into 2 segments, AD, we've got that segment here, and DB, I'm not color coding very well, we've got that segment there. There we go. Then the word problem says, if AD equals DB plus 4 and CD equals 12, find DB, AD, and AB. And the theorem that we're going to use here is the theorem where the altitude to the hypotenuse is the mean proportional between the segments of the hypotenuse. So when I was in school, we called this like hypotenuse section 1 and hypotenuse section 2. And AD then is hypotenuse 1 is to the altitude as the altitude is to hypotenuse section 2. Your teacher probably did something like that. All right, so we need some X's and some Y's. Get rid of some of this here. We're going to label, they told us CD is 12. Okay. We're going to let DB be X so that AD is X plus 4. So everything's labeled. Let's fit them into our equation. So we have X plus 4 is to 12 as 12 is to X, and cross multiply. You may cross railroad tracks. Cross multiply. 12 times 12 is 144. Okay, pause a little bit, get ahead, get your quadratic ready. All right, quadratic formula or completing the square. I like the quadratic formula, so I'm going to use that one again. X equals negative b plus and minus square root b squared minus 4ac all over 2a. So, a is 1, b is 4, and c is negative 144. Let's put those in. X equals negative of b plus and minus square root b squared 16 minus 4 times 1 times negative 144 all over 2 times a. 2. And I see again, as I'm writing it, got a negative there and a negative there. It's going to make this a positive. 16 plus, multiply that, 576. All right, I had to go back to a skill we learned in the radical unit and take 592 and break it down so I could figure out if there was a nice perfect square in it. 16 was the highest square I could find, 16 times 37. So I know a 4 will come out of here. And I can see that 2 goes into negative 4 and 2 goes into 4. So I can reduce nicely. Negative 2 plus and minus 2 square root of 37. Now remember, we have a word problem. We need to know, can x be negative? Well, x is the length of dB, so no. So our two answers would be negative 2 plus 2 radical 37. That one should be okay. And negative 2 minus 2 radical 37. That's negative minus something, rejected. So here is our value for x, negative 2 plus 2 square root of 37. And they want us to come up and find all of these sections. So dB is negative 2 plus 2 square root of 37. That's that. AD is this plus 4. So adding 4 changes this to 2 plus 2 radical 37. And then AB. AB is simply the sum of those two. So I'm just going to look at them here and add them up right here. If I add these two up, I end up with 4 square root of 37. So there you go. All right. So 25 goes through a bunch of parabola formulas, if you will. It says something we already know. A parabola is symmetric under a line reflection. Each real root of the quadratic function from y equals ax squared plus bx plus c is the image of the other one under a reflection in the axis of symmetry. So let's just get a feel for what this is doing, and then I definitely want to do number 26 with you. What this is saying, and I'm just going to sketch a parabola on here, any old parabola. We know a lot already. First of all, we know that these are the roots. And how have we been finding the roots? We've been using the quadratic formula. X equals negative b plus and minus square root b squared minus 4ac all over 2a. So what question A is asking you, what are the coordinates of the points at which the parabola intersects the x-axis? Well, this gives us two x values, and we know our y values are 0. So the coordinates are negative b plus radical b squared minus 4ac all over 2a, comma 0. That's one of the coordinates. And the other one is negative b minus the square root of b squared minus 4ac all over 2a, comma 0. So when we're using the quadratic formula, we're finding these x values. We already know the y value is 0. Okay, second question, part B. What are the coordinates of the midpoint of the points? So the midpoint of these 2 points, let me just sort of estimate, would be here. And you should know from geometry, for the midpoint, we're going to take our 2 points here, we're going to add up the x's and find their average. And we're going to add up the y's and find their average. So midpoint, remember, is x1 plus, whoops, let me redo that. x1 plus x2 divided by 2, comma, y1 plus y2 divided by 2. So if I go and do that here, okay, first of all, the y value is super easy. 0 plus 0 is 0 divided by 2 is 0. And obviously it's still on the x-axis. The x values, let me just do some work down here. We'd have negative b plus the square root of b squared minus 4ac all over 2a plus negative b minus the square root of b squared minus 4ac all over 2a. The sum of these would give us, let's see, all over 2a. We're going to have negative b plus negative b, so negative 2b. Positive square root minus square root, those go away. So we end up with negative b over a. We're supposed to find the average of that sum. So that divided by 2 actually gives us negative b over 2a. That's the x coordinate. That's the average of these 2 x coordinates for my midpoint. Well, that might look familiar to you. And the reason it might look familiar is because you should know the equation for the axis of symmetry, part C. The equation for the axis of symmetry of any parabola is x equals negative b over 2a. And the axis of symmetry is this line that is the line of reflection. There's our axis of symmetry. And notice the midpoint falls on the axis of symmetry. Awesome. The last question, part D, is asking you, turning point of a parabola. That's this part right down here, the turning point of a parabola. All they're asking here is what is the x-coordinate of the turning point. You can see it falls on the line of symmetry. The line of symmetry says that the x-coordinate is negative b over 2a. Now the coordinates of the turning point would be negative b over 2a, comma, what? How do we find the y value? Well, we'd need to know the function. We'd need to know the quadratic, and we'd put it into the function. We'd put that x value into the function, and we'd get out the y value. All right, so a few formulas, a little bit of review from geometry, fun stuff. Woo! All right, now a calculator problem. So this says gravity on the moon is about 1/6 of the gravity on the Earth. An astronaut standing on a tower 20 feet above the moon's surface throws a ball upward with a velocity of 30 feet per second. The height of the ball at any time t is equal to h of t, and they give us a really great little formula there. We're going to go and put that into our calculator. Thought I had this open. I must have closed it. So we're going to type in y equals negative 2.67. We're going to replace the t, the time, with x. Let's go to our y equals. Clear what you have. Okay. So negative 2.67 x squared right, plus 30t, we're using x, plus 20. And that looks good. The most important thing with these word problems now is finding a good window. So there's some clues in the word problem that I want to walk you through. First of all, our x value is time. And we're going to really want time, our x-axis, to start at what? How about 0? We're not interested in negative time. So when we draw in our y-axis, it's way over to the left. That also tells us for our window values on our calculator, we're really looking at an x minimum of 0. There's another clue in the problem that the starting value, the starting place for the ball, is 20 feet up. So if it's 20 feet up, I think, we know that our y values are at least 20. Okay? At least 20. Now it's going 30 feet per second. It's going to go higher than 20. But we know we're going to be messing with minimum of 20 there. So let's go in and let's try a couple values for our window. Hit your window button. We can't zoom 6 it. We won't find our graph. Let's set our time minimum to 0. Let's try 10 for x max. No problem. The scale is saying it'll give you a hash mark each 1 unit. Y min can stay negative 10. That's okay. It gives you a little room below the x-axis. And then Y max, let's try 100. A little trial and error here. Now my Y scale, since I'm going up to 100, I'm going to make it 10. Now hit graph. Oh, you can see what we're getting down here on my graph picture. So what do I need more of? It's not reaching my farthest x's, so I'm going to go change my x max. I need a little more, maybe x max 15. And I can't see the top of my parabola. So my y max needs to be more as well. I'll try 150. And I'm counting by tens, so my y-axis doesn't get so crowded. That's a great picture. I can see the entire parabola. I've got a little room below my x-axis, and I think I'm ready to go. So let's get some values from the calculator, graph that, and the question is, how long will it take for the ball to hit the ground? We're going to have to talk about what that means. Let's fill in our window. We did x max of 15, y min of -10, and y max of 150. Those were nice values. We could see the whole graph. All right. So I counted by tens on my y-axis. You show your scale if it's anything different. And I did go by seconds here, 1, 2, 3, 4. Use your table and get some good points. Use your table. If you don't know how to do that, you want to come in and get some help. Sketch in. Oh boy, my sketch was not very good. Sketch in my parabola. This point, I think I'm off on this point. 3. I'm looking at my, oh, that should have been up at 90. Sure did. Messed up that one right there. Oops. Okay. So the real question is, when does the ball hit the ground? How long? So they want the x value. How long for the ball to hit the ground? So it's over here somewhere. Here's our ground. Now we don't want to guess. So what could we do? Well, the ground has an equation as well. Remember this nifty little trick. Your x-axis is y equals 0. So then you're not going to see a graph unless you put the ball on. We can do our second trace intersect there. First curve, yes. Second curve, yes. We just want to go over to possibly where the intersection is, a little closer. Hit your right arrow key to move your flasher. And then let's hit guess. And your x value is 11.867162. check what rounding they want. I think it says, yep, to the nearest tenth of a second. So 11.9 seconds. There you go. Nice and slow. Lots of good word problems. See you tomorrow.